All right, folks. I guess we could do this again. I know. I keep thinking I'm just as surprised as the two people that actually watch this. So one of the things that has just blown my mind, as the meme says, throughout my career in our business is our ability to drill deep water wells. And sorry, land folks, but you have this massive drill ship, looks like a battleship on the horizon. It's an amazing sight coming in on a helicopter. There it is in 7,000 to 8,000 feet of water, being held in this pinpoint location through dynamic positioning, and it's drilling a well that's 25, 30,000 feet deep. I mean, how amazing, what kind of feat of engineering and technology is that? So I've always been fascinated with our ability to do it and do it successfully and actually incredibly safely. So it really shouldn't be a surprise when I learn about the United States and specifically the Central Intelligence Agency, the CIA, commissioning a drill ship to go out into the Pacific and recover a sunken Soviet submarine. You've piqued my interest. Um, a side note, the ship actually went on to drill wells for Texaco uh, in the Gulf of Mexico after this clandestine operation, if you will. But what I want to, I guess, bring it home to in this conversation is how this event in history relates to performance modes, specifically knowledge-based performance modes, and think about why we do our HAZOPs, our risk assessments, those types of operations, activities rather, before we get in. So let's set the stage. We're in the middle of the Cold War. Um, things between the United States and the USSR, the Soviet Union, are tensions are very high, Rocky Four high, and between the countries during this time period, and at this time you have this Soviet submarine, the K-129. It experiences a major malfunction at depth where I guess it's still classified to this day, or the root cause, if you will, was never determined. Um, it sinks at depth, and the sub is a complete loss. More importantly, all 98 souls on board do perish in this implosion explosion that takes place there in 1968. Um, so there's the after picture, and it's again taken late 60s, so the quality might not be the greatest, but it's impressive for the time. But the wreckage was in about 16, just under 16,000 feet of water. So again, I just mentioned drill ships today drilling wells in 8,000 feet of water. This is double. This is almost 16,000 feet of water in the middle of the Pacific, which at the time the Soviets and most everybody thought was an unknown location. Um, so the Soviets have this long period of silence from the K-129. They did try, although in vain, to locate the wreckage, and finally came to the conclusion that the ship was a complete loss, as well as the souls on board during this event. So, enter the United States, and using what was state of the art at the time, but various methods of triangulation, they were actually able to locate the wreckage, and they proved this. The picture that I showed earlier was actually a robotic remote control camera that they deployed rather from the USS Halibut, one of the United States' own submarines. And what they were able to identify was that the wreckage was basically in the middle of the Pacific Ocean. Again, 16,000 feet of water. And so the United States wants the sub. So how does the United States go about covertly recovering a sunken submarine? Well, enter the oil and gas industry. No, Bruce, wrong story. I mean, I am sporting some Stamper oil, but not today. Save it for another day. Glomar Marine. The CIA turns to Glomar Marine to build this special purpose drill ship specifically built to go and recover the sunken sub, all under this cloak of secrecy. The specifications of the ship are just incredible. And part of it includes this massive moon pool where the doors will actually open up and hopefully eventually allow for the wreckage of the submarine to be stored in the moon pool, which essentially turns into a dry dock after. But it's 1968, 69 at this point. How in the hell are we supposed to get the nuclear sub from 16,000 feet on the seafloor back up to this drill ship? Well, into the claw. Or as Lockheed Martin called it, or Lockheed rather at this point, the capture vehicle. It was specifically designed and built by Lockheed for the retrieval of this sub. And so what we basically have is this incredibly complex, awesome feat of engineering attached in both the drill ship and the capture vehicle. I mean, it's basically an industrial version of the claw game at Chuck E. Cheese. Yes, an oversimplification. Add in a drill ship. So 6 years it takes to build the Glomar Explorer, or what would be known as the Glomar Explorer, and the capture vehicle. Again, Glomar Explorer built by Glomar, and then the capture vehicle built by Lockheed, and then their anticipation is to put these two together to go and get what they call their target vehicle. So, but you've got this big old drill ship just gonna go randomly out in the middle of the Pacific and start doing this? You need a believable cover story to maintain the secrecy of the mission. And so enters a reclusive billionaire Howard. No, the real one. No, not him. The real one. Yeah, that guy. Yeah, Howard Hughes. Spruce Goose, same guy. Howard Hughes. The CIA approaches Howard Hughes, and they agree to use his company as a front for the operation. And so Hughes announces he's commissioned and built the Hughes Glomar Explorer to go out and mine the seafloor for manganese nodules. Seems legit. And so that's what they did. They build the ship, and it was so secretive that they actually designed and built a submersible barge to load the capture vehicle in, float it out to sea, sink it, drive the Glomar Explorer on top of it, and then bring the capture vehicle up and store it in the moon pool. So, oh, by the way, this was done in front of everybody, basically. There's a picture of it in San Francisco Bay. They actually brought the capture vehicle in right then and there, but again, submersible barge. So it was, in front of tens and hundreds of thousands of people in San Francisco Bay. It's incredible. So all the pieces are together. We're ready to go mine for those manganese nodules. Wink, wink. Ship gets on location, middle of the Pacific, 16,000 feet. Starts tripping pipe. And it's interesting because during that time, they're visited by a Soviet missile range instrumentation vessel, the Chasma. I mean, the ship sends helicopters over, they fly, they take pictures of the Glomar Explorer. Secret is still safe. Incredible. So again, they go down with the CV. They get to the capture vessel, or the target object, I'm sorry. They get to the target object with the capture vessel, and they begin to engage these claws that you see in the picture, which will wrap around the wreckage of the sub. So it's at this point where engineers realize that early on, they had to make an educated guess on what type of soil they would encounter at the location. And it was at this point, when they start engaging the claws, that they realized that the soil was much harder than they had originally planned for. Knowledge moat, error trap. So they also noticed that there was some significant hydraulic leakage that was happening from the CV, but at this point, you got 16,000 feet of pipe hanging from the drill string and the CV at the seafloor. Not much you can do but pump more hydraulic fluid, to be perfectly honest. And so they did, and the claws on the CV close in around the sub, and it lifts off, and they have the wreckage of the K-129 in their grasp. So now it's time to trip up. So as they're coming up with the pipe, they notice that, or not notice, but what happened is enough of the claw arms failed completely, broke off, and thus 2/3 of the wreckage actually sunk back into to the seafloor. They did maintain a portion of the submarine in the CV, and it was brought to the surface, where they identified that they had actually had the 2 nuclear tip torpedoes in the wreckage that had came to the surface. So they went back, they looked at the CV, and in their investigation, what they realized is that Lockheed, because they realized how much weight was going to be on the string, tried to use maraging steel, or not tried to, they did use maraging steel, which is a very strong type of steel, but it's not as ductile as other types, interlatent condition. And this they drove to as one of, if not the root cause on why those arms of the claw failed under those extreme conditions at the seafloor. Um, One thing I do want to mention as well is that they did discover crew remains from those sailors that had perished in the original um, K-129 sinking, and they were given a proper burial at sea. They actually filmed it and turned the video over to the Soviets. Um, but again, taking it back to human and organizational performance, I think about the massive amount of planning and engineering that went into this project, and the massive amount of planning and engineering that goes into our projects. And at the end of the day, the selection of the metal type, the steel type, used for really one small piece, though important, critical, of the entire operation is what ultimately caused its failure. And I'm a big fan of performance modes. It just makes sense to me the way my simple mind thinks. And so I'll paint with a broad brush. These folks worked in knowledge-based performance mode, heavy attention to the task, not very familiar with the task because it was the first time this was ever done, for 6 years. It took 6 years to build this out. And they did it pretty damn good, pretty damn successfully. Except for one latent condition to a critical component that really we had no safeguards in place to ensure that it had enough capacity to fail safely. And it brings me back to our conversations around HAZOps, risk assessments, operational readiness reviews, especially when we're dealing with these unfamiliar, high-risk tasks that take so much of our attention to be successful, and why it's so imperative that we as safety professionals try to move the conversation and shift the focus from looking or patting ourselves on the back when we don't have incidents to actually looking for the presence of safeguards. And this to me is a prime example, and yet another example how my career has ruined the way I watch television. There's actually a really cool documentary on this whole event on, I think it's on Amazon Prime, the raising of the K-129, Project Azorian, as it was known. And go check it out. And thanks for letting me ramble. Good night.